Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Part 24. Emergent Grammar Rules. When new effective laws appear. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. You are climbing higher in hierarchical generation of Episode 9, the generative grammar. In our last climb, part 23, we stood at the base of this book and saw the map of reality at different magnifications. We learned about scale-dependent productions, how the single detailed story of phi, when averaged and coarse-grained, yields simpler, effective descriptions at larger scales. We saw how the jagged coastline emerges from grains of sand, how the pressure of a gas emerges from chaotic molecules. That was our first step into hierarchy, seeing that the same reality can be truthfully described in different ways at different zooms. Today, we take the next, more magical step. We move from mere description to creation. We ask, when we zoom out and average, do we just get a blurry, simplified picture of the old things? Or does the act of coarse graining the phi field actually invent entirely new kinds of things? New entities, new forces, new laws of motion that were not written in the original microscopic script. Today, in part 24, Emergent Grammar Rules, when new effective laws appear, we discover that the answer is a resounding yes. The universe's grammar is not just simplified when we zoom out. It is enriched with new emergent rules that govern collective behaviors invisible at the smaller scale. Our anchor image is a vast flock of starlings at dusk, a murmuration. Picture it in your mind. 1,000 individual birds, each following simple local rules. Stay close to your neighbors, avoid collisions, match their speed and direction. Yet from this local choreography, something breathtaking and entirely new emerges. The flock itself behaves as a single, fluid, shape-shifting entity. It swoops, swirls, and pulses as one body. This fluid entity, the murmuration, obeys its own rules of motion. It has inertia, it can flow around obstacles, it has a distinct shape and behavior. Yet, if you zoom in to a single bird, you will not find the rule, swirl is part of a giant fluid cloud. That rule does not exist at the bird level. It is an emergent grammar rule, a law that appears only when many birds are combined and viewed as a collective. Today, we learn how the holophase field does the same. From the local interactions of microscopic phi, entirely new collective excitations are born: sound, spin waves, plasma oscillations, and they obey their own elegant effective laws. They are the murmurations of the phi field. Here is the elegant puzzle of this part. In the microscopic phi grammar, we have fundamental rules, perhaps equations governing individual atoms of the field. When we coarse-grain to describe large-scale smooth behavior, we might expect just a blurry average of those same atoms. But instead, we often find that the coarse-grained field supports new, organized patterns of motion, waves and oscillations that were not possible for an individual atom. How can averaging many simple things create new possibilities that none of the simple things possessed alone? And are these new patterns real or just mathematical illusions? The answer lies in a profound shift in perspective, from particles to patterns. The microscopic phi field might be described in terms of discrete, localized excitations. Think of them as the atoms or letters of the medium. But when we look at the smooth, coarse-grained field, we are not looking at the letters themselves. We are looking at the deformations of the page upon which those letters are written. A sound wave in a crystal is not an atom moving from one side of the room to the other. It is a coordinated, wave-like deformation of the entire lattice, a pattern where each atom oscillates slightly around its home position, passing the disturbance to its neighbor. This collective pattern is a new emergent entity. It is called a quasi-particle or an emergent mode. The most familiar example is a phonon, the quantum of sound, an emergent particle that describes the collective vibration of a trillion atoms. The phonon did not exist in the list of fundamental particles. It is a grammatical construct that appears when we write sentences about the collective behavior of the lattice. How does this emergence happen mathematically? It comes from studying the small oscillations of the coarse-grained field. Imagine the phi field has settled into a stable, uniform background state, like a crystal lattice at rest. Now, we give it a tiny collective nudge. We ask, what are the possible, stable ways this entire field can vibrate as a whole? We perform a mathematical analysis called linearization. We assume the vibrations are small and see how the equations of motion respond. This analysis invariably reveals a set of normal modes, specific, allowed patterns of collective oscillation. Each normal mode has a characteristic frequency, omega, and a spatial waviness, k. In other words, it has a dispersion relation. These normal modes are the emergent entities. They behave like new particles with their own effective mass, their own speed of propagation, and their own rules for interacting with each other. The microscopic phi grammar, through the simple act of asking about collective vibrations, generates a new emergent grammar for these phonons, magnons, plasmons, and more. Let's explore the triunity of emergent grammar rules. The time echo of emergence, the birth of collective rhythm. At the microscopic level, time is a frenetic dance of individual constituents, atoms jiggling randomly, electrons whizzing. The time echo is chaotic and fast. But when we excite an emergent mode, like a sound wave, we impose a new collective rhythm on the system. All the microscopic constituents begin to oscillate in a coordinated, lockstep fashion. This rhythm, the frequency omega of the phonon, is a new temporal order that was hidden in the noise. It is a slow, coherent beat that governs the collective motion, a tempo that belongs to the group, not to any individual. The space echo of emergence, the crystallization of collective shape. In space, the microscopic view is a disordered soup or a static lattice. The emergent mode imposes a new, propagating shape. A sound wave is a sinusoidal pattern of compression and rarefaction that moves through the medium. A spin wave in a magnet is a traveling wave of precessing magnetic moments. These are coherent spatial patterns that can be described by a wavelength and a direction. The space echo is this traveling texture, a shape that is a property of the ensemble, a stable deformation that can carry energy and information across the system. The motion echo of emergence, the dynamics of the pattern itself. The motion of these emergent patterns obeys new effective laws of motion. A sound wave packet propagates according to the acoustic wave equation, with a speed determined by the medium's stiffness and density. A plasmon oscillates at a characteristic plasma frequency. These laws are simple, often linear, and describe the dynamics of the pattern as if it were a fundamental field in its own right. The motion echo is this autonomous choreography. The emergent entity moves, interferes, and interacts according to rules that make no reference to the underlying microscopic dance. It has gained a life of its own. Now, let's locate this generative node on the master tree. We are on the Emergent Modes and Quasi-Particles branch within Book 9.6, Hierarchical Generation. This branch depends on the foundation of scale-dependent productions, coarse graining, and on the wave production grammar from Book 9.3. It enables the practical understanding of almost all collective phenomena in solids, liquids, plasmas, and even social systems. It is the bridge that shows how new, seemingly independent layers of physics, like acoustics, spin wave theory, or plasma physics, are actually governed by grammar rules emergent from the underlying phi dialect. To make this tangible, let's light lanterns from across the scales of science. A near lantern from an everyday crowd, the stadium wave. Imagine a sports stadium with thousands of individuals in seats. The fundamental rules are individual. A person can stand up, sit down, see their neighbors. Now, a collective pattern begins, the stadium wave. A section stands and raises arms, then sits as the next section does the same. The wave travels around the stadium. This wave is an emergent entity. It has a speed, a wavelength, the width of a section, and it can reflect or break apart. Its dynamics are described by simple rules about wave propagation. Yet, you cannot find the wave rule in the brain of any single person. It exists only at the collective level. It is a phonon of the social lattice. A middle lantern from condensed matter physics. Magnons in a refrigerator magnet. Your fridge magnet is a ferromagnet, billions of atomic spins all aligned north-south. The microscopic rules are quantum mechanical, involving exchange interactions between neighboring spins. If you disturb one spin, it doesn't act alone. It influences its neighbors, creating a wave of precessing spins that travels through the magnet. This wave is a magnon, a quasi-particle, the quantum of a spin wave. Magnons carry energy and magnetic information. They have a dispersion relation, omega versus k, that can be measured by scattering neutrons off the magnet. The theory of magnons is a powerful, effective theory that explains magnetic heating, damping, and resonance. It is an emergent grammar that perfectly describes collective magnetic behavior without solving the impossible quantum problem of every single atom. A far lantern from astrophysics. Plasma oscillations in the solar wind. The sun blows out a stream of charged particles, a plasma. The microscopic rules are the electromagnetic interactions between every electron and ion. This is a chaotic, turbulent soup. But this plasma supports collective waves, plasmons. If electrons in a region are displaced, their negative charge creates an electric field that pulls them back, causing them to oscillate collectively at the plasma frequency. This frequency depends only on the average density of electrons, a coarse-grained property. These plasma oscillations are crucial for how the solar wind interacts with planetary magnetospheres and for heating the solar corona. They are a clean example of an emergent mode whose properties, frequency, are determined entirely by averaged macroscopic parameters, yet whose existence is mandated by the microscopic phi grammar of electromagnetism. From the stadium wave to the spin wave to the solar plasma wave, a universal theme. Collective order creates new actors on the stage. The many, when coupled, can oscillate, wave, and flow in patterns that behave as simple, unified entities with their own rulebooks. Emergent grammar rules are the syntax of collective behavior. What then is the specific language role of emergent modes? They are new effective letters or words born from grammatical combination. They are the idioms of the Holophase language. An idiom like kick the bucket is not understood by translating kick and the and bucket individually. It is a new unit of meaning that emerges from the specific combination. Similarly, a phonon is not just the sum of atom 1 jiggles plus atom 2 jiggles. It is a new lexical item, a word, that refers to a specific collective vibrational pattern of the entire lattice. The emergent grammar rules are the dictionary definitions for these new words, telling us how they behave, how they combine, and how they move. The core question this part asks about phi is, given a stable, coarse-grained configuration of the phi field, a medium, what are the small, collective oscillations it supports, and what are the effective dynamical laws, the dispersion relations and interaction rules, that these emergent modes obey? We are moving from asking what the average is to asking how that average can wave and vibrate in its own right. What does this emergence do in the generative process? It creates new, simplified degrees of freedom, quasi-particles, that make complex systems tractable. It explains bulk properties like heat capacity, electrical conductivity, and optical response in solids and fluids. It provides a unifying framework. Wildly different systems, crystals, magnets, plasmas, all support emergent waves, each a dialect of the same vibrational grammar. It's how higher-level laws can be both autonomous, they have their own logic, and dependent, they are derived from the micro-rules. Now, stability and breakdown. The description in terms of emergent modes is an accurate, stable, effective theory for small amplitude collective oscillations around a stable background. It holds as long as the modes are well defined, meaning their lifetime is long compared to their oscillation period. It breaks down in two key ways, through nonlinearity and through disorder. If the oscillations become too large, modes start to interact strongly and scatter off each other. The simple, independent quasi-particle picture fails. If the medium is highly disordered, like a glass, the collective waves become scattered and localized. They lose their coherent wave-like nature. Within its domain, linear response of an ordered medium, The emergent grammar of quasi-particles is powerfully predictive. This brings us to our empirical anchor, falsifiability. The claim that emergent modes and their laws are derivable from the coarse-grained phi dynamics is a precise numerical hypothesis. The central claim: for any ordered medium, crystal, ferromagnet, plasma, etc., modeled by a specific phi configuration, the dispersion relations of its low-energy collective excitations, phonons, magnons, plasmons, as measured by experiment, must match those derived from linearizing the equations of motion for the coarse-grained phi field. Furthermore, properties like the speed of sound, the specific heat at low temperatures, and wave scattering cross-sections must be quantitatively predicted by this emergent quasi-particle theory. A concrete measurement scene: phonons in a simple crystal. Take a single crystal of table salt, sodium chloride. At the microscopic level, it's a lattice of sodium and chloride ions held together by electromagnetic forces, a complex phi-based interaction. We perform inelastic neutron scattering. We fire a beam of neutrons with known momentum and energy into the crystal. The neutrons scatter off the crystal, and we measure the final momentum and energy of the neutrons that come out. When a neutron creates or destroys a phonon in the crystal, it gains or loses a precise amount of energy and momentum. By mapping out how many neutrons scatter with a given energy change for different momentum transfers, we directly measure the phonon dispersion relation, omega as a function of k for various vibrational branches. The past condition, validation. We first construct a coarse-grained model of the crystal as a spring mass system, an effective phi model where stiffness represents the interionic force. We linearize its equations to predict the theoretical phonon dispersion curves. The measured dispersion curves from neutron scattering match the predicted curves in exquisite detail. Not just the general shape, but the exact frequencies of acoustic and optical branches, the slopes, sound speeds, and the curvatures all align. Additionally, the predicted low-temperature specific heat of the crystal, calculated from these phonon modes, matches the measured heat capacity. The emergent phonon grammar, derived from the coarse-grained phi dynamics, successfully captures the collective vibrational reality of the crystal. The fail condition, falsification. The measured dispersion relation deviates fundamentally from the prediction. Perhaps a whole branch of vibrations appears that the theory cannot account for, or the measured sound speed is off by a factor of 2. More decisively, if we find a material that clearly has a regular crystalline structure but exhibits no sharp propagating phonon modes in neutron scattering, just a broad, featureless blob, it would mean the collective vibrational grammar has failed to emerge. The microscopic phi rules, even after coarse graining, would not yield stable, wave-like solutions. This would falsify the very idea that ordered phi backgrounds necessarily give rise to emergent phonon-like degrees of freedom. It would point to a deep flaw in our understanding of how collective order works. This falsifiability ensures that the beautiful concept of emergent quasiparticles is not a philosophical metaphor, but a hard, testable component of the holophase grammar. Let's cultivate a practical recognition skill. You can train your perception to spot emergent grammar in any situation where a group of interacting individuals develops a coordinated, large-scale pattern that seems to obey its own, simpler set of rules. Listen to the rhythmic clapping that spontaneously synchronizes in a concert hall. Initially, clapping is random noise. Then, a collective rhythm emerges and locks in. This rhythm is an emergent mode, a clappen. It has a frequency and stability that is a property of the hall's acoustics and the crowd's coupling, not of any individual clapper. Observe traffic flow transitioning into stop-and-go waves on a busy highway. Individual cars follow simple rules: accelerate, brake, maintain distance. Under high density, this system can spontaneously generate traveling waves of high and low density that move backward through traffic. These jammetons are emergent entities with a characteristic propagation speed. They are predictable phenomena studied in traffic science, yet no driver intends to create one. Consider the coordinated flashing of fireflies in certain species. Each firefly has an internal oscillator and adjusts its rhythm based on neighbors' flashes. The result is a sweeping wave of synchronized light across the entire population, an emergent spatiotemporal pattern, a bioluminescence wave, obeying its own dynamics of synchronization. Whenever you see a collective rhythm, a propagating group pattern, or a synchronized pulse that seems to have a life of its own, you are likely witnessing an emergent grammar rule. The many have composed a new sentence with its own verbs. We must connect this insight inextricably to our holophase journey. In the previous part, we saw that zooming out gives us a smoother picture. Here, we see that this smoother picture is not inert. It is alive with new kinds of motion. The coarse-grained phi field is not a dead average. It is a vibrant medium capable of supporting its own stories. Stories of sound, spin, and plasma waves. This is hierarchical generation at its most creative. The grammar generates new grammatical categories as we ascend the scale ladder. We haven't added new fundamental ingredients. We've simply discovered that the grammar of phi, when applied to collective, patterned states, automatically defines new verbs and nouns for describing those patterns. If you want to see the full mathematical derivations and exact equations behind this idea, the linearization procedure, the diagonalization to normal modes, the derivation of quasi-particle dispersion relations, you can search for Holophase on Zenodo. There you will find the scientific papers that this audio journey is built on. Let us pause and appreciate our vantage point in Book 9.6. We have now seen two phases of hierarchical generation. First, scale-dependent paraphrase, coarse-graining. Second, and now, the emergence of entirely new grammatical rules from that paraphrase. We understand how new layers of reality, with their own apparent laws, crystallize from the microscopic chaos. But our journey up this book is not complete. We have seen new rules appear, but how do we navigate between these different layers? How do we know when to use which grammar? This leads us to a powerful systematic tool, renormalization as grammar simplification. In the next part, we will see how the universe itself provides a procedure, a flow, for moving seamlessly between scales, simplifying the rules as we go, and defining the precise boundaries where one effective theory hands off to another. Before we end, the mandatory zoom out to hold our scope. Emergent grammar rules, quasi-particles, collective modes, these are all patterns in the coarse-grained phi bar field, which is itself a pattern in the fundamental phi. We have added no new substances. We have simply observed that when phi arranges itself into certain stable, large-scale paragraphs, media, those paragraphs have their own intrinsic ways of vibrating. And those vibrations can be described by a new, effective dictionary. One field, phi, plus its infinite tower of derivative questions, plus the principles of coarse-graining and linearization. From this, the universe generates not only things, but the laws of motion for those things, at every scale. As we conclude, hold the image of the murmuration of starlings. The flock is real. Its fluid, swirling motion is real. Yet it exists only because of 1,000 individual birds, each following its own simple script. The Holophase universe is this murmuration on the grandest scale. The fundamental phi field is the script for each starling. The stable media, crystals, magnets, fluids, are the flocks. And the emergent grammar rules, the laws of sound, spin waves, plasma oscillations, are the beautiful, coordinated dances that these flocks can perform. Dances that belong to the group alone. We have learned to listen for the rhythm of the flock, and to understand that this rhythm is a genuine, powerful voice in the chorus of reality. Salam, and peace be upon you.